Hello, Berlin. I'm Sonam and my talk deals with biases in language model and data and its interpretability. So, a little bit of background about myself. I work as an AI researcher at Sama Technologies. Previously, I have worked as a software lead in an IIT Madras incubated startup. And before that, I also served as a visiting faculty in robotics and computer vision. These days, I am mostly working in the field of NLP and its application in biodomain, model compression, and fairness in AI. And I'm so grateful for the organizers like PyCon GE and PyData Berlin to give me the opportunity to share some of the insights. So let's get started. So the topics we will be covering today are language model. What is language model? What are the different kinds of language model? Transformers, the building block of of a new NLP, the building block of Bert, etc. Why is it important to check for biases in language model? Examples with OpenAI and Google Translate. Contextual and non-contextual language model, non-contextual language debiasing. We will also see contextual language model with the example of Bert. We will see Bert visualization, debiasing of Bert. We will see importance of interpretability tools, interpretability visualization, and open source library like AIX 360. So the first question arises: what is uh, what is what is language model? So a language model learns to predict the probability of sequences of words. So example, there is a sentence, Tom is a bad cat, and that the language model is trying to predict the probability distribution of each word given the whole other words in the sentence. There are two typical kind of language models: statistical language model and neutral language models. So statistical language models are uses traditional statistical techniques like n-grams, hidden Markov model, and certain linguistic rules to learn the probability of the word distribution in the sentence. Whereas in neuro language model, and these are the new players in NLP town that have surpassed statistical model in effectiveness, and they use different kind of networks to learn, model language like your Elmo, your Bert, etc. Then comes pre-trained language models. So a lot of many tasks, this NLP tasks are very GPU intensive, very training intensive. So a good way to go through is to train it first on a GPU and then do the transfer learning and use it in different cases. Like for example, Hugging Face has a lot of different kind of pre-trained models, and you can just take it off the shelf and use it according to your like suppose if you have to do document classification, you can use one of the models pre-trained on the language, and then use it in your downstream task. So in the language model, there are two kind of language model. One is autoregressive, that predicting based on the past words, predicting new words based on the past words. So for example, Tom is a bad blank. So autoregressive will use all the words used before and then try to generate a new word. Whereas if we see autoencoding, it will try to predict the probability of the masked word. So for example, Tom is a masked cat. So it will try to predict, is it good, bad, dirty, etc., etc., based on its previous words and past words. So it's future words and past words. So it's bidirectional. So if we see different examples of pre-trained model, there's Bert, there's OpenAI, there's Elmo. So Bert uses bidirectional transformer OpenAI uses a left-to-right transformer. Elmo uses the concatenation of independently trained left-to-right or right-to-left LSTM to generate feature for downstreaming tasks. Now, if you see downstreaming tasks, these are the ultimate tasks that you have to perform, like name entity recognition, sequence labeling, documentation classification, etc. If you want to visualize how the POS looks, you can easily visualize their embeddings using the train models, using TSNE, a library. Now let's come to an important point. Why is it important to study language models? Why are we so focused on mitigating biases or debiasing it? So the use of AI in sensitive areas, including hiring, like criminal justice, healthcare, provisioning, or resource allocation, has stirred a huge debate in the community about biases and fairness. Because if you can imagine, our own world is so biased, our data is so biased, so the models will try to predict the same kind of biases that we have now because our data is biased. So AI is being shaped by flawed data and full of societal bias data, where Muslims are considered more violent and females are considered less smart for a job. So these biases in data will not only be baked in the models, but it could actually increase the intensity of biases as well. And the issues, algorithmic fairness is one with the massive societal implication, the allocation of welfare schemes, welfare resources to prioritize life-saving to surgeries, and all these things, and job application, all these things are going to get be based on AI. And if we let the data dirt the model, so be able to mitigate it. So one of the example is Google translation. So if we see, there was a tweet by there was a tweet where someone tried to translate Finnish, which is a gender neutral language, to English, and the results was he is a journalist, he is a leader, she is exhausted, she has a grandchild, he works, she has headache, he has a great car, she is taking care of the child, he takes care of things. So we already see that he is being related to journalist, being a leader, and owning something, where she is related mostly to caregiving and to having a headache or taking care of the child. So we use these things in everyday, like recommendation system and for chatbots, etc. One more example could be in OpenAI Playground. So if you give a gender neutral name like Taylor loves her job, she is a great. So it feels like she's a great teacher, she loves her job. Whereas if you give it like Henry is a great at his profession and he is a great, so it comes out he's a great doctor. So we already see the model are associating a female character more with a teacher and a male character more with a doctor. Now, after seeing all these examples, we will see what kind of language models are there. So the first and basic language model comes as non-contextual language models, which includes methods like skipgram and cbow. And so what is the meaning of non-contextual method models? So non-contextual models, the meaning of a word does not depend on what context it is being used. So Apple and Apple products, maybe it could be used in different ways, but their embedding will be same. So let's buy Apple products, Apple is healthy. They both will have same embeddings, and the context will not depend. The embedding will not depend on the context. So as we can see, it will create a lot because there are so many examples uh, like Run Away from Bear and Bear Grylls. I like Bear Grylls. Both Bear will be same embedding. So it create kind of non-context scenarios uh, on the other words present. Like let's see debiasing technique and how we can do it in contextual methods, how we can remove biases using projection method. So first important method is the projection technique in which original embedding is projected onto a common gender axis. The results look something like this, where you can see that teacher editor has been reduced. What's happening is we are trying to check both uh, your conformist, like your preserved gender roles like king, queen, brother, sister, whereas also taking in consider of uh, where stereotypical gender roles like teacher, editor, doctor, nurse. So if we try to check, the teacher need nurse has been faded away, the correlation has faded away, and whereas in your king and queen there is still a correlation. So it removes the hard association with preservation of the gender roles. If you want to calculate the embedding and calculate the gender direction, project all the embedding away from this axis and plot the results. So the results will look like something like this. So we can include the past great works that have been done for removal of biases. The first work done was like Man is to Computer Programmer as Woman is to Homemaker by Tolga Balbuski, where he created two kind of embeddings and tried to see if they are like equidistant. So study of gender stereotypes in word embedding also deals with the debiasing with soft bias correction. It provides a method for modifying an embedding to remove gender stereotypes such as association between the word receptionist and female while maintaining desired associations such as now there was another great work published which says uh, that the projection method actually doesn't work. It's by lipstick on a pig, which says you are actually hiding the gender biases instead of removing the gender biases by projection method. Then a paper came called Measuring Stereotypical Biases in Pre-trained Language Model that deals with measuring the stereotypical biases with different kind of scores like CMS score, LS score. Then came as uh, a null projection method, which was removing information from neural representation. And the method is based on repeated training of linear classifier that predicts a certain property. We aim to remove that, followed by projection of representation on their null spaces. So there is just a projection of all these undesired characters of displayed on gender, and they are null out by a matrix. Now let's discuss the contextual language models. The word embeddings in which the context is being used, like here the Apple product and Apple will have different embeddings, example Bert and Flair. In 2017, a paper called Attention is All You Need and that led to the transformer, led to the like use of transformers, and that changed everything. And the reasons it changed everything, it was easier to train. Pre-trained model can be fine-tuned, can be trained on unsupervised text. So you can easily parallelize the text, you can easily transfer learn, you can train the model, you use the pre-trained model in your downstream task. How is it able to do that? So here is the transformer model architecture. You could see different encoder and decoder stack that you can now segment it out easily. Which one is the encoder, which one is decoder, and there's different kind of input output processes. But the main attention is happening over here, like there's a query, key, and then there's a value. So encoder decoder attention between input sequence and output sequence. Then there's self attention, there's multi-head attention. Okay, but basically what we want is to take query and find a more similar k by doing dot product for q and k. And the closest query key product will have the highest value, followed by a softmax that will drive q dot k with the smaller closest values. So with the softmax, it will look something like this. And then we find the most attention over there. So So we saw the architecture of transformer and how it tries to, calculate attention to each of the word, like multi-headed attention models, with the help of multi-headed attention model and self-attention models. And now Bert is the biggest example that makes use of this transformer and attention mechanism that learn contextual relations between the words. Like suppose Tom is a bad cat, so cat is really it's kind of has attention to both Tom and to bad. Okay? Because previously uh, there was no mechanism by which one can know that cat is related to Tom because it was mostly related to being bad. But now you can have multi-headed attention. So cat can be both Tom and cat can be bad as well. Here the positional encoding, sentence embedding, token embedding you mask one of the words and at the end you will get the probability of that masked word or your next prediction models. And so there are two kind of BERT models. There is both a masked language model and there is next prediction model. If we see the visualization of attention in BERT, we can see the designer is associating itself more with his than her. And this is the biggest, this is what bias means, right? That you're giving more weightage or some gender is giving more contribution to the designer than, the other gender. So in that case, you can use fine-tune model. How do we fine-tune the model? So these codes are available. I will make them available on my repo. And this is how you first try to mask one of the words, one of the tokens, and then you kind of provide the predictions of this output, and then softmax's prediction, find the weightage, and you get top 5 weightage of that. The top 5 maximum weightage of the predicted tokens. Okay. So the end results, if we want to see, it will look something like this. The lawyer wanted to help the designer, but bracket she refused. So she will be masked, and then the masked token will be predicted. So here we can see it is trying to predict he with a weightage of 0.4 and she with a weightage of 0.16, right? But when you fine tune that, when you fine tune your model, that is like, making new kind of association based on data. So if you provide it with a gender neutral data, if the data set is gender neutral, it tries to kind of decrease that. Now, if we can see the mass prediction of him is reduced to 0.01, which is a lot of progress. So if you want to visualize everything, I had uh, I had this. So Bert is in red and green is the fine-tuned bird. So each of the word is representing each of the point is on the x-axis is representing different kind of profession, and on the y-axis, the distance between his prediction uh, to the profession. I mean, he's to the profession prediction. So we can see the distance has reduced a lot, and it's kind of like settling down. So at last, if we investigate the culprit of bias model, we find out that the underlying data is responsible for biased models, and there should be ways to find out what kind of biases lie within the data. And then there are many tools in our explainability and interpretability tools available, like AIF 360. So biases in data can occur because of sampling, omission of certain groups, and exclusion and underrepresentation of certain groups. So prejudice, bias, exclusion, omission, insight we get from data of the model, we have to be very careful about how conservative that bias is. For example, if we see here in the probability grid, y-axis is the age group and x-axis is the gender group. We see females are much less in as a defaulters of loan as compared to male. Only 19% as compared to male, which is like 23%. So there could be numerous reasons for that. Maybe females are better at managing the credits debt, or men have more burdens, or maybe that females are not getting as much as credit as male groups. So there could be numerous reasons which could not be inferred from here. So visualization of data set is based on privileged and underprivileged group. Biases will impact protected feature that is privileged and underprivileged group. Representation, there can be a lack of representation or an overrepresentation of the underprivileged group. The model will learn either too much or too little about the group. So the distribution is centered around, it could be centered around underprivileged group or could be far away from the underprivileged group. As an example, we can see in recidivism, what happens, there are two features of confusion matrix, there are two features of risk prediction made by Compass, is recid and the ground truth. So we see that people who were, seen that they will again do the crime are much more in African American confusion matrix than Caucasian confusion matrix. It's actually totally opposite. So how do we quantify the data set? So we quantify the data set based on your statistical parity difference and disparate impact. They both have formulas according to which one of them is a favorable group. Now, pre-processing of biases. Pre-processing based on feature engineering. Sometimes continuous features capture bias because there are so many sparse area where the model can fill the void with assumption. Balancing or resampling under representation problem can be fixed by balancing the data set, which is done by XAI library. XAI library has a balance function that does this by downsampling and upsampling of group representation. There are some tools called smooth or synthetic minority oversampling technique, or reweighing. Initialize it by specifying, grouped and fit the transform the data as you would with any of the scikit-learn encoder or scalar. So there are in-processing, post-processing, all focused on a balanced classification and equalized odds for privileged and misclassification treatment for misclassification. So at last, AI is going to be a big reset in our society, and it's on us and now if we want to carry our current biases from the day with the data to the future, or we want to make the future a better place. I'm available at Twitter. All the materials will be available on GitHub under Ikigai groups, which I'm planning to open source where you can also contribute about the data set. You can contribute unbiased data set. You can contribute visualization tools. You can actually, we're trying to make an augmentation model based on these unbiased data. So Ikigai is going to be open sourced. You can avail it from Sonam 95. You can any day connect with me on LinkedIn, and I will make everything uh, uh, public on Twitter, LinkedIn, GitHub, etc. So thank you so much. Thank you so much for your time.
All right. Okay, I think we have some questions online. Can you hear us?
Hey everyone. Yes.
Perfect. Okay, the first question comes from James. What do you think of the role the size of the model plays in perpetuating bias? Any thoughts on the stochastic parrots paper?
If you could repeat the question,
Yes.
I didn't get the question.
What do you think of the role the size of the model plays in perpetuating bias? And do you have any thoughts on the stochastic parrots paper?
The size of the model like depends on the data set, and the more data set is like bias. So it's a round circle. Like the more data is biased, the more data. Even heavier models like Bert are highly contributing towards biases in models. So it's all a round circle. The less unbiased data set we have, like we know biased data set, you can search it online. It's called Winograd, which I have used for fine tuning. So that could be like better, just making data set better instead of making the models heavier. It's better.
Okay. Second question. Is it better to use the projection technique to remove bias or to mask pronouns and retrain the model?
So they were for totally different use. Like one was the debiasing was for non-contextual uses like Glove. Uh, Glove is an embedding, whereas masking was for contextual language models like Bert. So yeah, so they have totally different use. Non-contextual has a lot more examples like fast text, Glove. I could give you byte pair or different. You can search it like non-contextual versus contextual. So I have covered both and how you can debias in both those situations. Yeah.
All right. I think that's all the question we have online. Let me check again. Yes, so we can open it up to the audience here in the room. Does anyone here have questions for our speaker? I don't see any raised hands. If you're raising your hand, please shout. Okay, so that was a short Q&A. I think the second talk should begin in 10 minutes here. And thank you again for your great talk, your great presentation, and thank you for answering these questions. Yeah, we would love to have you here in Berlin, but this was
Thank
also
you
great.
so much. Yeah. Thank you. Bye bye.